The adapter pattern is a structural design pattern that allows incompatible interfaces between classes to work together by providing a wrapper that translates one interface into another. So let's create a scenario that will help you to understand this pattern and the pattern's use cases. So say that we have a video editing application that allows users to upload a video and change the color of the video. The application provides preset color options for the user to select, such as black and white or midnight purple. So as you can see here, we have the original video with color. It then goes through some sort of black and white algorithm, and we finally get the edited video with all of its color removed. In this case, the video is made black and white. So the classes that change the color of the application are built by us. They are sort of our own part of our own code base, our own custom code, and these classes implement a color interface, so some sort of common interface, so that we can use polymorphism to treat these classes in the sort of same way. So here's how the application looks. So we just have a sort of basic video class here. We have no methods and fields, but let's just pretend this class represents some sort of video. We then have a color interface which has an apply method, and each apply method takes a video class, and this is the video that we are going to work on. So we're going to apply a color to this video. So we then have our sort of concrete color classes. So here we have a public class called black and white color, which implements the color interface and therefore has an apply method which accepts a video to apply this black and white color to. And in a real application, this would be some complex code to apply a black and white color to a video, but here we're just logging, applying black and white color to the video. We also can have other color classes, of course. So here we have a midnight color which implements color and has an apply method which takes a video that we can apply the color to. We then have our video editor class which has a video field, and we pass a video to this video editor via the constructor, and we then have a method called apply color which takes some sort of color object and then calls color.apply and passes the video that we want to apply the color to. Okay, so using this solution in a client, we first create a video editor by calling new video editor. We pass the video editor a video that we want to edit, and we then call video editor.apply color, and we can pass any color object that we want to apply to the video. So in this case, we are applying black and white color to the video. So this is all looking good so far, but we then decide to install a third-party library into our application that allows users to apply more types of colors to their videos, so more complex color options to the videos. So the problem is that all of the concrete color classes are expected to implement our custom color interface and have an apply method. But the concrete color classes from the installed library don't implement this color interface, meaning that we can't pass them to our video editor.apply color method like this. So you can see here that this rainbow class is a color class from the installed third-party library, and we don't have access to this code. And you can see here we can't just pass it to this apply color method because this is expecting an object which implements our color interface, and of course this third-party class doesn't implement our custom color interface. So as mentioned, we cannot modify the third-party library code to make the color classes implement our color interface. So how do we solve this? So we can solve this by converting the interface of the third-party color classes to a different form using the adapter pattern. So far we can't use this third-party rainbow class because it doesn't implement our color interface, and we can't make it implement color because it's inside of a third-party package. So here's the sort of situation drawn out in your UML, where we have a video editor with an apply color method where we can apply some sort of color, so any color that implements this color interface. And we have our own sort of custom color classes such as midnight purple and black and white, which implement this color interface. We then have our sort of third-party color classes such as rainbow, and these have some sort of update method which needs to receive a video. However, we can't pass these to the apply color method because they don't implement our color interface. So let's take a look at how we can solve this issue. So we can create a rainbow color class that implements color and is composed of the third-party rainbow class. We can then call the apply method in rainbow color, and inside the apply method call whatever methods that we need to call from rainbow to apply the filter. So we essentially adapt the class to a different form. So let's explain that again. So here we have our video editor. So again, we just as before, nothing different here. We apply a color and pass it some sort of color. So any object that implements this color interface. And this color interface has an apply method which accepts a video. So now this is the new class that we've created. We've created this rainbow color class. This is our own custom class which implements color, has of course an apply method which takes a video, and then within the apply method we can actually call the rainbow class or the rainbow object dot update and then pass the video. And this rainbow color class that we've created is composed of, so it has a field of type rainbow. So essentially we've adapted this third-party rainbow class into a different form. We've adapted it into a color object. Okay, so rainbow color, this class that we've created, is the adapter. It's converting the interface of the rainbow class, so the adaptee, into a different form, and that form is color. So let's now implement this in code. Okay, so just a quick reminder of what we have so far. So we have a video class, which is just a class that represents some sort of video. We then have a color interface, which describes what a color class or a concrete color class should look like. And all colors should have an apply method that accept a video object. We then have our concrete color classes, such as black and white color, which implement the color interface, have an apply method that takes a video, then the apply method applies the color to the passed video, and midnight color is also a concrete color, similar to black and white color that implements the color interface. We then have our video editor class, which has a field which stores a video to edit. We pass the video via the constructor, and we have a method called apply color where we can pass a color that we want to apply to the video. So that's what we have so far. So let's now create the video class from the third-party library. So I'm just going to create, let's actually create a folder. So this is kind of going to represent a third-party library. So I'm just going to call this package, and in here I'm going to create a rainbow class. Okay, so let's say that colors from this third-party library require some sort of setup. So we have to call a setup method before we can actually use the color. Okay, and maybe this would be some sort of method that we could pass some configuration options, such as, I don't know, the brightness of the color, or I don't know, anything like related to the color of a video. but we're just going to leave this as a simple method called setup, and I'm just going to log setting up rainbow filter. Okay, and then I'm also going to create a method called update, and this is going to be basically this a similar sort of method to our apply method. So we're currently calling the method apply. The third-party library is going to call the method update. Okay, and this takes a video and it applies the color to the video. So I'm just going to say applying rainbow filter to video. Okay, so this sort of represents what our third-party rainbow color class looks like, and currently we can't use this because it doesn't implement the color interface. So what we can now do is we can create an adapter class that adapts this rainbow class to use our color interface so that it can be used by our video editor class without having to modify this source code. Okay, so let's create a rainbow color class, and the rainbow color class is one of our own classes. It's not part of this sort of installed package. So inside of the adapter folder, we're going to create a class called rainbow color, and this is going to implement our color interface. And if you remember from the UML, we need to store a field of type rainbow, and this is composition. So rainbow color is composed of or has a rainbow object. So let's also create a constructor, and we can pass the rainbow object in here. Okay, and then in our apply method we can actually interact with our sort of third-party rainbow object now. So we can call rainbow.setup. So this is something that the third-party library requires us to do, so we call setup, and then once we've set up the rainbow object, we can call the update method and pass the video. So now we have a rainbow color class which implements color that we can now pass to our video editor apply color method, and use this rainbow color now as we would any other of our color classes. So we can now apply rainbow color to our videos just like the other colors. So let's now go into our program.cs file and let's see if we can apply a rainbow color. So let's call this rainbow color, and inside of rainbow color we need to pass the rainbow object. So let's see, and this is part of the third-party package. So there we go. So now we can apply our rainbow color just like we would our custom colors. So you can see here that rainbow color is a wrapper that translates one interface into another. So now to use any other color from this third-party library, we can create a new wrapper or adapter class to make it compatible with Video Editor, satisfying the open-closed principle. So we actually created our adapter via composition. So you can see here our rainbow color adapter class is composed of a rainbow object, and this is our third-party color that we have adapted into an object of type color. So we can also use inheritance to create our adapter classes. So let me show you how we can use inheritance instead of composition to create an adapter class. So let's create a new class called Rainbow Adapter. And what we're going to do here is we're going to inherit from the third-party rainbow class. And we're also going to implement the color interface. So let's implement that by pressing Command and dot and implement the interface. So what we can do here is, let's just have a look what we did before. So we can see here, because rainbow color, our sort of previous rainbow adapter, is composed of rainbow, we have to call the methods on this rainbow object that we passed into rainbow color. Whereas here, we can call the methods directly because they've been inherited by the rainbow class. Because you can see here, this third-party rainbow class has a setup method and an update method, and we are inheriting them, so we can just call them directly, like this. Okay, so this does exactly the same as what our rainbow color adapter did. So these adapters both do the same thing, but one's using inheritance and one is using composition. So with inheritance, the rainbow methods can be called directly. Now, the problem with this inheritance approach is that it's not as flexible as using composition, because in C#, a class can only extend one class, and in this case, the rainbow adapter is extending this rainbow class. And in this case, this is okay. It's okay to use inheritance here because color is an interface. But you can see that inheritance is less flexible than composition, and therefore composition should be preferred. And that is because if color wasn't an interface and it was some sort of class that we'd need to extend, then you can see that C# would give us an error, because this rainbow adapter would then need to extend two classes, which is not allowed in C#. So as you can see, composition gives us more flexibility than inheritance, and therefore should be the preferred option.